Okay, this is example 3 on page 221 from section 4.4, and this is called fabricating a box. You also see this problem in quiz 4.4a, and we may have 1 or 2 or 3 of these quizzes, so you best know how to do this. We're going to do this not like they do it. We're not going to solve this not like they do it in the book with the quadratic formula, but we're going to use the calculator because most of these problems you'll need a calculator to do. So let's kind of read it. It says an open top box is made by cutting congruent squares of side length x from the corners of a 20 by 25 inch sheet of tin, bending up the sides. How large should the squares be in order to make the box hold as much as possible or to have maximum volume? So it's like, let's say this is our sheet, and if we cut these squares out from the corner. Now again, I kind of drew the illustrations over here, so these are the squares we're going to cut out the corner. Now the length of this piece that we started with is 25 inches and the width is 20 inches. Okay, but if we want to talk about when we fold these up, what our box will look like, if we take this, what I did was I took a little note card that's at the same size and I cut those squares out, and then I folded up the sides to make a box like this. I did this in class. It's going to look like that. Now you can see that it's not going to have the same length as the original sheet because it's going to be shorter because we had to fold up the edges. All right? So those are the little corners that are missing. So the actual length of the box will not be 25 inches, but it's going to be 25 inches minus an X here and an X there. So this is actually going to represent the length of the box because I folded it up. And you can see how it is shorter than or smaller than the original piece because we're folding up those sides. Okay, if that makes sense. So therefore, the length of my actual box will be 25 minus 2x, and the width will be 20 minus 2x. And the height is going to be x because we're going to fold that up. So we know volume equals length times width times height. You learned that a long time ago, I hope. So we can just multiply this out, or just substitute in, and this will be volume. And these are all going to be as a function of x, so I don't have to worry about any constraints on this problem. This is a little bit easier because of that. So that's going to be 25 minus 2x times 20 minus 2x. That's the length, and the width, and the height is just going to be x. Now this is our primary equation, and this is what we want to maximize. So we're going to take the derivative, and hopefully we'll be able to find where it changes from positive to negative, so we'll have a relative maximum. So we multiply this out. And then 25 times 20 is 500. And then I've got negative 20 times 2 is negative 40, and a negative 50 is negative 90. And then negative 2x times negative 2x is positive 4x squared. And we still have to multiply that by x. So volume as a function of x will equal 500x minus 90x squared plus 4x cubed. And then we'll just rewrite this in descending power. So volume as a function of x will equal 4x cubed minus 90x squared plus 500x. Okay? Then if we take the derivative, that's what we want to, we want to find the maximum. So this is what we want to take the derivative of, so we can check in the slope, see where it changes from increasing to decreasing. It's going to be a relative maximum, and that value of x is what we're looking for the x, the side of the square. And this is just going to be 12x squared minus 180x plus 500. Now this is our derivative, so where is it v prime equal to 0 or v prime undefined? Well, it's just a polynomial, so it's not going to be undefined, so we set this equal to 0. So we want to see our solution when 12x squared minus 180x plus 500 equals 0. So this is where we'll go into our calculator and try to figure that out. Okay. So that's what we're going to put in. I'll put this over here. Hope you can see all the keystrokes here. I think we can see everything there. So turn this guy on. Go to Y1. And so we'll put in our 12x squared. 12x squared minus 180x plus 500. Okay, and there's my derivative. That's my derivative. So I'll just try zoom 6. And there we have it. Now remember, this is a parabola, so there's a little bend here you can see, so it looks like it's going to come down like this. Now remember, this is our derivative. So our derivative here is changing. The values here are positive because they're above the axis, and the values here are negative. So this is where the derivative is changing from positive to negative. These are all positive, these are all negative. So I'm looking for this point here, which is going to be my critical number. So we want to find out where it's crossing that line, so we're going to look for the 0. So we'll go to second, calculate, go down to 0, press enter. Now it says left bound. Now right over here I'm at x equals 0 and y equals 500, so I'm up here where y is positive. So what we have to do is hit our corner, our arrow here, and move over here from 0 until we get to around this area to find our left bound. So I'll press my corner. You see how y is getting smaller, but it's still pretty big. So I'll just keep holding it down there until I get, oops, there it is, I saw the little marker. Now you may see the marker, you may not, but you want to watch over here because here my derivative is positive and here my derivative is negative, so right over here in between, here I'm changing from positive to negative. Remember, if the slope goes from positive to negative, up like this, positive to negative, what do I have? I have a relative maximum. That's what we're looking for, the maximum. The value of x will make my function, or my volume, maximum, because I have the derivative of the volume. So that's where it's positive. One more it's negative, so I'm going to go back, and that's going to be my left bound where it's positive. So left bound, I'll press enter. And then I'll cursor it down one more to make the y negative, and now that's going to be my right bound. Even though I can't see it, I can tell it's negative 13, point, etc. So I'll press that. I don't really need to guess, and I'll press enter. And now I've got my 0. So x equals 3.68. Now we want to round these off usually to 2 places, but we want to carry that into our calculations. But right now x would be 3.68. Okay. Now I want to save that because I'm going to use that to find the length, which is 25 minus 2x, and the width, which is 20 minus 2x. And this is the height. So we'll go to home screen, second, quit, go to the home screen, and then we're going to store, and this will store whatever was on my graph. So we'll just put that in, and we're going to store that someplace. We're going to call that alpha and A. That's going to put that in letter A. And I press enter, and there we have it. Now if I want to find the other values, the 25 minus 2x, then I can just go 25 minus 2 alpha A, enter, and that's my length. And I want to store that because I eventually want to find the volume, so I'll press store, and I'll put that in alpha B, and enter to check that. And then I want the width, so that's going to be 20 minus, again, 2 alpha A, enter, and that's 12. And that's going to be my width. Now I can either store that in alpha c or I can just multiply that, but I would want to write these down. So 25 minus 2x, which is the length, is 17.6, and we'll round it off, so 6.4. And then 20 minus 2x, which is the width, equals 12.64. And then if I want the volume, I want all three, so I could just take this. I could store this in alpha c if you want, so store alpha c. And then if we want to find the volume, it's just going to be alpha a times alpha b times alpha c. Enter. And there's your volume, 820. So the volume, that's going to be my max volume. So my maximum volume, move this over just a little bit here. My maximum volume will be 820.53. And I think these were on inches, so this would be inches, 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 and this would be in cubic inches. And move this over just a little bit more so you can see the answers. And there you have it. Okay? You can go back and pause and check this and make sure everything makes sense.